Hello, CascadiaJS friends. I'm James Steinbach, and today we're here to talk about responsive components, present and future. And as is often the case, before we understand the present and can aim for the future, we should understand the past. Media queries. And today's talk is going to focus on why we want more and how we can get it. Media queries have been around for over a decade. They were part of Ethan Marcotte's 3 principles of responsive web design: fluid image sizing, flexible grids and layouts, and media queries. Media queries allow us to change our CSS or other code based on something that's true about the browser. That could include the browser's screen dimensions like height or width, its pixel density, how our user is holding or rotating the screen, or even user preferences like contrast or reduced motion. But what about the size of the element itself? What if we want an element's styles to change based on its own size, not the size of the viewport or the entire browser window? What do we do for that? Right now, the answer for a while has been first, figure out what size the element will probably be in a given responsive layout based on your media queries, and then use multiple media queries back and forth to toggle your CSS changes on and off. And it looks like a wall of text, and it kind of is, and that's kind of the point. I don't want you to learn from this code. I want you to not do this. I've done this. I remember about 7 or 8 years ago, I had a layout for a component that had to go like this. At its smallest size, single column mobile devices, we used a narrow CSS. Then when we get to wider mobile devices, we needed the wide version of the component's CSS. Then when we went to 2-column layout, but the columns are still narrow, we went to the small size CSS. And then again, when the columns were wide enough for that component, we bounced to the wide version of the CSS. That's a ton of work, and it's not a ton of good work. It's just repetitious. It's hard to maintain. And it gets worse when you consider that all that code we just looked at didn't even accommodate different containers, like it being in the content box or in the sidebar. So let's talk about how to make components that can respond to their own sizes. And there are several techniques that are currently in our toolbox. We can use them with tremendously solid browser support. Here we go. These are CSS techniques. I have 3 of them to talk to you about today. First off is going to be based on dimensions or ideal widths of children inside of the responsive component. By using flex wrap and setting a flex basis with a certain width on a component's children, we can essentially get the component to shift layout from columns to rows as there's room for the components to stack horizontally. Jeffrey Croft is one of the earliest people promoting this technique. If you want to see it real life, we've got a CodePen demo here. The 3 components you see on your screen are the exact same markup. There's not a stitch of HTML difference between them. There are also no media queries or anything like that CSS-wise. It's one block of CSS covering all the components. The only thing that changes is the width of the component itself. And you can see we go from really narrow 1 column to wide 1 column. And then we get down to the bottom and we've got 2 columns, and the responsive component just snaps because now the flex basis on both the image and the content area can fit inside of the component itself. With flex wrap and flex basis, we can trigger layout changes based on the size of a component's children. Very handy. We can do this today in all major browsers. Another cool trick is with Flexbox is called the Holy Albatross. And that sounds weird, and it is. That's what Hayden, the author of this technique, named it. And this uses flex basis and a calc function to change a component's layout, the layout of a series of children, based on a width for the parent, not based on a bunch of ideal widths on the children, but based on the width of the parent. And with a calc function, you essentially pass the parent's trigger or breakpoint width into that, and it can shift between column and row layouts at that pseudo breakpoint. Here's what it looks like in real life. The code has a container width at the top with a CSS variable, then same ideas before, flex and flex wrap. And then the children are all set to flex grow as possible. But then the basis is a calc that multiplies or takes 100% away from the container width, multiplies it by 999, and all of it is fun, complicated math. But essentially, the end result is it toggles between columns and rows at the 720 pixel mark. And it looks like this in real life. Got an animation that just gradually changes the size of the content area. And when it's narrower than the 720 marker, we jump to single column, but when it's wider than 720, the 4 elements are stacked stacked horizontally in a row. And this is done without any media queries. And again, it's Flexbox, it's super well supported. CSS Grid has a helpful technique for this as well. This is another one that adapts based on the width of a child. And this is great for like gallery layouts where you've got a whole bunch of things in just a giant grid, and you want the grid to change column counts as your screen has room for more columns. What this grid template columns value will do with the repeat function is fit as many 200 pixel columns into the area, into the container as are possible. But during that kind of stretchy space between an even number or a set number of 200 pixel columns and the opportunity to stick one more column in there, the one fraction unit will distribute the extra space evenly between the columns. So each column will just kind of grow until there's room for another column, then boom, it'll snap one extra column in. And then all the columns will grow together until there's room for an extra 200 pixel column, and then boom, we'll have another column. And that looks like this in real life as the images load. There we go. As we change the size of the grid container based on the 200 pixel ideal width for the children, as soon as there's room for a third, fourth, fifth column, the grid automatically connects it or adds it to the grid layout. And we've got a grid, a layout that responds to its own size based on the ideal target size or width for a column within it. These are all handy layouts. They cover different ideas. The first one can be a little more fine-tuned. The second one and this one are more or less just for evenly spaced grids. But with these techniques, we've got a lot of power. What you've probably noticed, however, though, is that all that power applies to layouts. We haven't changed any colors. We haven't changed any font sizes or line heights. We haven't done anything with a CSS property that isn't layout related. It's all been flex and grid. And that's the way it is. There is a CSS technique, a function called clamp that you can use with min and max functions inside of it to create fluid font sizes and line heights at scale dynamically with fixed minimum and maximum boundaries. But clamping technique, I included it here just to be thorough, but it is based on viewport size, not component. So this technically isn't part of responsive components, but clamp does show up in a lot of the blog posts about it. So for the sake of appearing complete, I've included a brief slide pointing it to you. You may find it useful, though it's not strictly a responsive component technique. Those are some CSS techniques we've got in our toolbox that are really widely supported. There's almost no trouble using those in modern browsers today. There's also a JavaScript API that does some really fantastic stuff for us called the ResizeObserver. And this is a browser API that allows an element to watch its own size and then add or remove classes would be the most common use case, or any other DOM manipulations really, as needed based on the element's own size. You can read more about this here at MDN, Mozilla Developer Network's documentation. And it works like this. RO is going to give us a new instance of the ResizeObserver, and it's going to take a function that has entries which are looped through. The const size block is, it's just a normalization block because Firefox gives you an array of border box sizes for some reason on a single DOM node, whereas WebKit and Chromium give you a single object, which is border box size. So yeah, size isn't part of like the essential code other than normalization. But then here we go. If the size is inline size or in a horizontal writing mode, like right to left or left to right, if the item's width is greater than 480 pixels, add the class wide. If it's less than 480 pixels, then take away the class wide. And then we set the ResizeObserver to observe a DOM node. And with this, the ResizeObserver will keep track of how wide the container is and change its class. And then you can key any CSS you want to onto that modifier class. And in a real browser, it behaves like this. We're going to change the width of the card. And as soon as the wide class disappears, we see a change from green to blue. We're also, since the ResizeObserver can touch anything in the DOM, adjusting inner HTML to always give ourselves the exact pixel width of the card, just for a reference. But ResizeObserver will let you essentially create classes to use in CSS that will respond exactly to a component's size. And because we're using classes, we can then use any CSS properties, not simply layout, not only flex and grid. Now we can change colors and font sizes and any attribute we want to. any part of the styles we want. We can modify it based on a class. This is really awesome browser support-wise. I'm sorry, my head is covering. This is upper 90s support-wise. And the only browsers that don't have support for ResizeObserver are Edge before it got Chromified back in 18 and down, and IE, and then a couple of mobile browsers, Opera Mini and UC browser for Android. There is a polyfill for the desktop browsers like Edge and IE, and for Opera Mini and Android, there's a really handy progressive enhancement tip I have for you, which is if you write the small version of the CSS, the mobile browser targeting version first, and then the modifier class happens when the element's wide enough. Since Opera Mini and UC browser for Android are mobile devices, you're almost never going to need that wide class. So you can let progressive enhancement be your friend and not even bother probably with the polyfill in mobile browsers. But there's a link to the polyfill if you need it. You can avoid memory leaks as you should, just like event listeners in JavaScript have the add event listener and remove event listener APIs. We've got a ResizeObserver observe and ResizeObserver.unobserve. So you can take down a ResizeObserver if you're going to destroy an element or that kind of thing from your component language or your SPA framework. Now, let's talk about the future. Let's talk about what's coming next. And this is a part that really, really excites me. And hopefully by the end of this talk will really excite you as well. And that's container queries. And you might have been thinking, but weren't they called element queries for a bit? And the answer is yes. And even before that, they were called selector queries. If you're paying attention and keeping track of all the names and dates in this talk, you might notice that the date on Andy Hume's selector queries repo is just about a year away from Ethan Marcotte's responsive web design, where media queries were really popularized. It didn't take us long at all to realize, yeah, usually the browser viewport is an okay way to change our CSS, but sometimes the size of the actual element really does matter. So, selector queries. Andy wrote a JavaScript library that lets you put a media query style syntax into a data attribute that would then toggle classes on and off. And kind of like before there was ResizeObserver, this essentially had the same function, but with a data attribute syntax as opposed to a bunch of JavaScript to set everything up and tear it down. And it was before browsers had ResizeObservers as well. Just a couple years later, the language is starting to standardize and shift a bit toward element queries, which hung on for a few years. We got Tyson's article here in Smashing Magazine. Then by 2015, we're seeing the lines blur again a little bit. Philip's talk from CSS DevConf still identifies this technique as element queries, but calls them container-based responsive web design. And as time passed, another 6 years have gone by, and now it seems like browser vendors and implementers have settled on container queries as the main description for this technology. Why did it take 10 years, 11 years almost, to get from Andy Hume's original selector query JavaScript library to browser vendors starting to implement it now? The answer is loops. Here's what would happen in this. The query syntax in the second block is fake. Just imagine it does what you think it does. Okay, so first we take our element and we set its width to 400 pixels. Boom, that's how wide it is. Then we add a query that says if the element is at least 300 pixels wide, so far that's true, then change its width to 200 pixels. As soon as we do that, the query is no longer true, and the element goes back to 400 pixels wide. As soon as that's true, the query does match, and the element becomes 200 pixels wide. And as soon as that's true, the query doesn't match, and the element goes back to 400 pixels. And as soon as that's true, and you see what's going on here, we've got a loop. Every single time the element changes its width, it either enters or exits the condition, and it's never going to allow the browser to lay the page out correctly. So browser vendors had to find a way to make sure that didn't happen. And that's part of why it's taken the better part of a decade, rather more than a decade to get here. So the solution we have today is container queries. And I want to make sure that I give credit loud and clear to Miriam Suzanne. Everything I've learned about container queries, I've learned from Miriam. I know that sounds like the poster outside of kindergarten classrooms, and it's largely true there too. But yeah, tech has a bit of a problem sometimes where people will repeat other people's work. And sometimes it happens that somebody in a position of a ton of privilege, usually a dude, will repeat the work of somebody from an underrepresented group in the tech industry and end up, whether deliberately or not, getting and taking all the credit for that. And I want to make absolutely certain that doesn't happen. So all credit here goes to Miriam. If you want to just give her a giant round of applause from home, we can go ahead and do that. It sounds really feeble because it's just me right now doing the applause, but hopefully you all did too, and Miriam could feel or sense that. But yeah, all the credit that from the next section goes to her. If it sounds amazing and awesome, then I'm clearly communicating what I've learned from her. And if it sounds weird or wonky, what I say next, then I've misunderstood it and misquoted it probably. But yeah, tons of credit to Miriam. She's done a ton of great work with the CSS working group in defining and pushing the spec forward. So ton of credit to Miriam, and off we go. First thing we have to do to break the loop is create a container. Creating a container, here we've got page content and page sidebar are both set to be containers, disables content-based sizing. What that means is, normally in a browser, the children inside of an element affect the element's height and width. When it doesn't, it's weird to us. Anybody remember doing layout with floats back in the older CSS days, like 6-8 years ago? And when you floated everything inside of a container, the container suddenly had no height and we had to have clear fixes on all of our layout wrappers. Yeah, fun times. That was a pain in the butt to fix. This is necessary. The browser intentionally disables content-based sizing. So the size, the height, the width of all the children inside of an element declared to be a container will not affect that container size. So its height and width essentially collapse to 0 unless you've got something else in the styles giving it width, whether that's explicit height and width based on percentages or pixels or what have you, or the fact that your container is placed inside of a flex or grid container that are giving it size based on grid columns and flex stretching. So right now the spec is a little bit work in progress, but at the moment we need to set our container to size, layout, and style. And we set the container type to inline size. And as I mentioned earlier, inline in CSS and in JavaScript, where the same measurement language is used, applies to the size of an element from the beginning or end to a line of text. And it's not the same as width, although it usually is. In horizontal writing modes, like left to right, languages like English, German, Greek, French, Russian, etc., we've got horizontal writing mode, so inline size is left to right. In right to left languages like Arabic and Hebrew, still horizontal writing mode, so inline size still describes the width from the right to the left edge. But if you've ever done a localization for a site in a CJK language, a character set, Chinese, Japanese, or Korean, the writing mode becomes vertical in certain of those layouts, which means that a line of text goes from the top to the bottom of a column, and then instead of lines going down a paragraph like English, you've got lines going across a page, creating columns. In that case, the inline size automatically becomes a height. The browser just rotates to match your writing mode. Really handy syntax. So essentially we're saying for right to left and left to right languages, this container is going to be focused on its width, and it's going to be a container. Then we can style its children. And that's so far all we've needed to do. Set up a container, and then give our widget its narrow CSS, and then when the container is at least 480 pixels, then give the widget wide CSS. Pretty fancy. And so far, pretty manageable. This is not like the most complicated CSS syntax that we've ever seen. This is so far quite short and quite simple. I like it. And this is going to find the nearest container in the DOM. So if a widget is nested inside of a container that's the sidebar or that's the main content area, it will find the nearest parent in the HTML tree. Similarly, you can put containers inside of other containers. And if that's the case, it will find the closest one. And that's the container that will be queried for this CSS. Each widget will query all of its potential containers, and then the closest one will be used as the measurement. Third, and optionally, if you want to, if you need to, you can name your containers. It looks like this in the CSS. Besides already having set up our content and sidebar as containers, we're going to give them names now. Inline size, as a type, as we saw before, but now our main container is called main, and our sidebar container is called sidebar. And now, if we want to do something different in the main rather than in the sidebar container, we can give our widget CSS some nuance to match which container specifically is being queried. Now, if the widget is in either of the containers, but with another container in between, my expectation, so far, again, this is still work in progress, my expectation is that the nearer container would be queried and we wouldn't get to the main unless, there was room for things higher up the cascade that haven't been overridden yet. is I think how CSS would treat that. And here's what this looks like in a real browser. And I am running supporting browser here. So now we've got the same layout code, the Flexbox, that we saw in my very first CodePen demo. But now, because we're using container queries, we're changing a bunch of properties, some rotation properties. We're inverting all the colors. We're really messing with the border radius. We're even making the fonts bigger. We've done all these changes because container queries can happen. So you can do so much more than just shift your layout now that container queries are a thing. I could have put all my layout changes into a container query, absolutely. In this case, I chose to keep the layout changes in the more stable, really widely and thoroughly supported CSS Flexbox, and just put the fun stuff, as it were, the decorative things that can be safely progressively enhanced into the container query. So now let's talk about everybody's favorite slide in the talk, and I'm sorry. Yeah, this is supported so far in Chrome, ... Canary, ... again, behind a feature flag. Yeah, and all of a sudden everybody goes from container queries, let's go use them now, to maybe in 2022, I hope. And just to give ourselves a reminder of how quickly browsers can mobilize when the specification is stable and people know where we're going. Several months passed, not years, months, between the first major browser to support CSS Grid the right way and the final one. Grid support rolled out in barely half a year. Chrome is currently not just like describing a specification, but actually supporting container queries with a set spec. The CSS working group is still ironing out some details of the specification, but as soon as that's done, there's no reason to expect browser vendors, other than their own internal priorities, which is kind of a tough situation some days, to delay or to have months and months or years of delay on this. Flexbox was hard. There were like multiple levels of Flexbox support in 3 consecutive IE releases, 9, 10, and 11. And it was just a real challenge, and it took years to get Flexbox kind of everywhere. Grid popped up, and every browser that was going to be able to support it, we're not counting IE anymore, was supporting it in a matter of months. This is my speculation. This is not canonical. This is just James talking here. But I don't expect container queries to have a really long support ramp once the specification is nailed down. There's a Can I Use page already for it. You can bookmark that and follow along as additional browsers open up support or feature flags. And there's a polyfill. If you really want to use this, but most of your users aren't using Chrome Canary with a single feature flag enabled, yeah, most of them aren't, I can promise, then you can use Jonathan Neal's polyfill called CQFill, and that's an awesome 2-part polyfill. It works with PostCSS on your style sheet and with client-side JavaScript to keep everything synced up and running the way you'd expect a browser to handle this correctly. Very handy. So if you want more information, here's everything you need to know, from the initial proposal to Miriam's really detailed explanation of where it's been, where it's going, all the way down to the draft specification at the CSS Working Group's GitHub page. So now what can I do? This is always a great question at the end of a talk. Can we make this practical? What can you do? Well, besides using it in that one magical supporting browser situation right now, use the polyfill. Browser vendors care about that. NPM stats, CDN statistics, anything that's publicly available. If browser vendors understand a specific polyfill has a ton of traction and is being used more and more widely, that's going to do 2 things. 1, it's going to help them prioritize the feature itself. And 2, it's going to give them a strong indication for what the community of developers will expect the syntax to look like. So use the polyfill. That's an awesome way to go. If you have a reason to use it, use it. Even if it's just progressively enhanced and everything falls back and breaks perfectly cleanly in a nice fallback layout, great. But still, get the polyfill going if you want to move this forward. You can follow the CSS Working Group's specification discussions and join in. They're all hosted in GitHub issues, so there's a really low barrier of entry. All you have to do is have a good GitHub account and have something to contribute to the discussion. Additional use cases, edge cases that haven't been considered, please join in. And then as browsers release a page in their implementation or feature trackers for container queries, by all means, jump in there and use your votes to help browser vendors prioritize this feature if it'll be useful to you. So thank you so much, everyone. It's been great talking with you today. Hope you're enjoying Cascadia. Again, I'm James Steinbach, a senior engineer at Auth0. And if you want to keep this conversation going, you can find me at JD Steinbach on Twitter, github.com, And I would love to continue this conversation beyond the Q&A coming next, into the next few weeks if you would like. Thank you so much and enjoy the rest of your conference.
Hey, welcome back. Those of you who attended in 2019 might remember me telling a lot of dad jokes while I was emceeing. So I'm going to say that doing my entire intro with my mic muted was an intentional dad joke. Yeah, buy that. All right. So if you got questions for James, please drop them in the widget. We're doing this real quick, so we already have a couple here. One is, how soon will container queries be available?
Yeah, great question. As I mentioned near the end, I don't have an exact answer on that, but my expectation is based on how well browser vendors collaborated on CSS Grid. It could be half a year to a year of total time elapsing before all browsers support it. But again, that's just speculation. I don't have an inside track on secret browser vendor info that confirms that or anything.
All righty, good. And okay, so here's a question. Are there any other techniques for components that can respond to their own size?
There is one that I didn't mention. We could have completed the trio and had CSS, JavaScript, and HTML techniques. If you use an iframe around your component and put media queries in the iframe, they will respond to the iframe size, not the page size. So in theory, yes, you could wrap all your responsive components in iframes. I didn't mention that because that's very clunky and also really challenging to manage in an SPA where you're passing data back and forth.
All right. And I'm gonna, I'm taking some stuff from your AMA, and what I'm just going to pronounce this as it's spelled. Mrs. Anderson posted, if you need to know how to turn on stuff in Canary, go to chrome://flags, and that will give you all the experimental flags that you can turn on. But you do need to download Canary, correct?
Correct.
Very specifically. So, are there any risks depending on the polyfill?
Risks, if you treat it as progressive enhancement in the first place, don't put anything that's going to like mask your content or decrease usability into the container query, then no, there wouldn't be a risk. You could even progressive enhance it all and not worry about the polyfill. Using the polyfill, of course, you'd want to make sure that you're bundling your app so that it's only going to browsers that need it, and you're not including it in a bundle that goes to every single browser as it moves into Chrome stable and then gets supported by other browsers. You don't want to be shipping all that unnecessary code.
All right. Well, thank you very much. So we've got a few seconds left. I just want to ask everybody who's at the live things to give James a hand. He won't be able to hear it, but your fellow attendees will. And we're going to go on to the next speaker, Jessica Campos, talking about window.open. Thanks, James.